All right, so now we're going to talk about the different ways we can classify numbers. And so that includes our number subsets. And so we have the following subsets. We've already talked about rational and irrational. And so this rational is any number that can be written as a fraction. A fraction. A terminating. Or repeating decimal. All right, and then irrational basically is not rational. So anything that cannot be written as a fraction, terminating, or repeating decimal. Real numbers are all numbers, for what you guys know so far. And the reason we have to specify real versus, say that it's a real number is because, yes, mathematicians get very curious and they have to have an answer for everything. And so they invented imaginary numbers, but don't worry about that. That's an Algebra 2 thing. So then things that we haven't talked about, natural, whole, and integers. And actually you just didn't know it. Natural numbers are the numbers we naturally count with. So numbers naturally count by. So when you think about that, we start at 1, right? I'm counting sheep in my sleep. I start at 1, 2, 3, and we just keep going. So basically, positive whole numbers starting at 1. Whole numbers are our natural numbers plus 0. So when we talk about whole numbers, we're adding 0 into the mix. And integers are our whole numbers and their opposites. Opposites being negatives. All right, so we're going to make a Venn diagram to show this. So it's, best I can do is what I'm drawing. All right. So this big one that I drew, those are my real numbers, which is going to encompass everything. All right. I'm going to try to make, and I know I'm not making circles. Now, if you remember what a Venn diagram is, these are going to be my rational. A Venn diagram is a way that we can show things that are same and different, and anything that overlaps is the same. So when I'm drawing this Venn diagram, if you notice, these last several have been within each other, and that they're all encompassed. And then I'm going to come over here and I'm going to make one for irrational. Maybe. All right. So here's the Venn diagram. Starting from the innermost are natural numbers. So that's like 1, 2, 3, and it just keeps going. This could include 1,000, 1,000,000, whatever. As long as it's a positive whole number. Whole numbers, we just add a 0. So it's our natural numbers, because natural numbers are within the whole number box, plus the number 0. An integer is a natural number, a whole number, and this is where we start introducing our negative. So like -3, negative square root 9, because our natural number, I could put the square root of 4 here. It's a perfect square. Square root of 4 is 2. 2 is a natural number. It is a whole number. It is an integer. So integers just introduce our whole numbers. That could also be like an improper fraction that becomes a whole number. So like negative 30 over 5. Our natural numbers, again, that could be like 30 divided by 6, or as a fraction 36, because 30 divided by 6 is a whole number. Just some food for thought. All right, rational is where we start introducing proper fractions. So like 2/3, or a negative 1/7, or 0.3 repeating, or 0.5. Those are all rational because we've got fractions, we've got our repeating and terminating decimal. All right, all numbers are real numbers, and then irrational, that would be like our square root of 2, square root of 80. Pi is an irrational number because it is never, the decimal never repeats and never ends. So this, if you haven't drawn it, pause, draw. This is going to help you because now you're going to do some classifying of numbers. And our first example here is 15. So I'm going to come in here, and 15 is a number I can naturally count to. I would naturally count to, right? 1, 2, 3, all the way to 15. So it's a natural number. So I know that it's natural. If it's natural, then it is also whole because natural is encompassed in the whole. So it is also a whole number. If it is a whole number, then it is also an integer. If it's an integer, it is also rational. And then they are all real. Now, so how did that work? I knew that I wanted to find the smallest box it fits in. In this case, it was the natural numbers. And then from there, I just follow it all the way back out to real. All right, so here I have negative 1.232. I don't have the ellipse, the 3 dots at the end saying that it continues. So this to me is a terminating decimal. And terminating decimals fall under rational numbers. And so that means that our answer here is rational. And then the only other one, so starting at rational, the only other box is my real. So rational and real. All right, so now we have square root of 45. So if we go back to our perfect squares, square root of 45 falls between 36 and 49. So it is not a perfect square, and since it is not a perfect square, that means that it is irrational. And irrational numbers are also real. So that's how that works. So again, it is not a perfect square, so it's in the irrational circle, and irrationals are also real. All right, next one. 121 divided by 35. Well, it's a fraction, and it is not equally divisible. And so since it is a fraction, it is rational, and all rational numbers are real. All right, negative 6, or square root of 16. Oops, wrong direction. So square root of 16 is 4, and it's negative. And so since it's a negative 4, that starts out as the integer. And so we're going to write integer. And then it would also then be rational because integer fits into our rational box, and real. 21 thirds. And so 21 thirds is 7. 7 is a natural number, so it's going to be natural, whole, integer, rational, real. Because if it's a natural number, it is everything but irrational. natural, whole, integer, rational, real. And that's how subsets work. Find the smallest group it goes in, and then it is everything outside from there. And that is it for today's lesson. Until next time, 8th graders.